So I've got a quick one here. I want to find the value of x for which this converge. So I need to find the test for convergence to know what the value of x would be. So for this one, I would like to use ratio tests. So we want to use ratio tests. So what does ratio test for convergence says? It says the limits at n tends to infinity, and I do a n plus 1 over a n equals to L, and we say that converges when L is less than 1, and diverges when L is greater than 1. So I will use this knowledge to find the value of x that will make this converge. So what we want to do first is our an is the question, minus 1 over n 3 raised to the power of n, and our an plus 1 as required in the formula will be that anywhere I see n, I'm going to write n plus 1. So it's going to be n into n plus 1 minus 1 over n plus 1, 3n plus 1. And of course, this would be that 1 will cancel 1. So my an plus 1 is equals to x raised to the power of n over x, that's n plus 1, 3n plus 1. So now that we have our values all together, then I can put all of this into this question. So let me quickly do that. So know that we are aiming through L less than 1. That's our answer, whatever we get. So I'm going to put this over this. So it's going to be that the limit as n tends to infinity, and the absolute value of this, that is xn over n plus 1 to the power of 3n plus 1, which is our an plus 1. Then we divide it by x as our an. These are xn minus 1 over n 3 to the power of n. Okay, so this is what we want to work with. So knowing this fully well, this can be changed to the times. So I will have the limits as n tends to infinity, then this will be x to the power of n over n plus 1. Then let me just say this is 3 raised to the power of n times 3 from the law of indices. Then times it will swipe to n times 3 raised to the power of n over x raised to the power of n times x raised to the power of minus 1. For still the law of indices. So it means that this takes out this, then this takes out this. Now 1 over the inverse of 1 over x will be x. So this will be, in other words, the limit as n tends to infinity, the absolute value of n over 3 into n plus 1. Then don't forget that I have 1 over x here. So 1 over x will bring the x up. So it will be the limits as n tends to infinity. Then x comes up. So I have x into n over 3 n plus 1. So let me just open the bracket so it will be easy to do. So 3 n plus 3. So because I want to find n to infinity, I will divide by the highest power of n. So that would be that the limits as n tends to infinity. So if I divide this by n, xn over n over 3n over n plus 3 over n. So this cancels this, this cancels this. So I'm left with x, the absolute value of x over 3. This is our L, because 3 over infinity will tend to 0. So I have x raised to s over L, and this will only converge if this is less than 1 from the law, right? So which means that the value of x for this series to converge is that for x less than is over 3 less than 1, so x has to be less than 3 before the series converge. So that's the value of x. X have to be less than 3. So thank you for watching, and don't forget to like, share, and also subscribe to this channel so you can see more videos of this nature in the subsequent views. And I'll see you in the next video.